and Gavin, welcome to class. They have been working this entire time, meaning only a couple minutes, maybe a few. Well, theoretically, they've been working some of that time. On this example right here that I'm like bouncing around to the notes, boop, 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 that one, which is very similar to the one on the page before. I had them write down endeavor number 5. It's also up on the wall in a little bit snazzier form with some extra stuff we'll write down in a second. But ultraviolet voodoo, it's basically a breakdown of the, for everybody else, it's good for you to start tuning in. It's basically a weird rearrangement of a product rule. It's basically a weird rearrangement of a product rule. Because in a product rule, second D first plus first D second, we kind of have two separate pieces. The problem is there is no direct straight back from a product rule. So instead, there's kind of this weird rearrangement that occurs because the only thing that we can have without an integral is that little original product of u times v. But we're given one specific integral. We have to have this whole variation because of what we saw yesterday. It's messy, it's weird, but there is an ultraviolet voodoo, uv minus v du, in an integral. That kind of gives us a way to memorize it or remember it. But here's the long story short. In an original problem, which you guys have one right down here, everybody, yeah? In this original problem, we can break it down. We can change its form, which sometimes changing its form is the difference between being able to solve and not being able to solve. Or not being able to solve the original problem to being able to solve the variation, the change, the transformation. So, what can we transform? What can we equate? How can we change an integral? We have to look at it in two pieces with always some sort of multiplication, okay? You always have some sort of differential already in there that is going to be a part of the dv. Now, maybe we can steal someone else along with it, but the dv is, in a sense, a derivative that is going to need to be integrated. So I need to go back to v in this little ultraviolet voodoo. I need v by itself, not with a d. Integration is going to have to occur, which is what you saw me do yesterday right here. When I went from sine to negative cosine, that's not a derivative, that's an integral. Everybody good? Ultimately, I basically integrated both sides. When I integrated both sides, I was able to get back to v and then back to, well, I was able to integrate, so it was possible. If you're ever unable to integrate something, it better not be in the dv spot or else it will be impossible to proceed. Now, there has to be some other piece. The whole problem is that I have multiple pieces that seem unrelated or are not helpful to each other with u sub, like the good old-fashioned stuff we've been playing with. Maybe a little bit more difficult problems, but still. So that other piece, the u, gets to be derived. And hopefully, when we get over here to the other variation, the other integral, what couldn't be solved is now possible. The dv got integrated to become v. The u got derived. Usually, that derivative is where everything gets better. And isn't that where yesterday got better? When we went from u to du, what was an x became a 1. So when you went to put the v and the du together, ultraviolet u times v, so x times negative cosine of x was starting off the formula, minus an integral of a negative, hence why it became a plus. V du, cosine of x with a 1, got that. I can integrate him real easy. Dun, 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 dun. Don't forget your c, right? So, when you guys went to go look at this example that was very similar, what did you make your u? What? Well, I can derive him, but wait, I can derive anybody. When you derive x, what does he become? Simpler. But yes, 1, right? So then, if this is my u, then what had to be my dv? Everything else. So sine of 3x dx. Why have I been having you do integration with mental math? Do you really want to have to draw integrals on both sides and start writing u substitution if there's another u? So who would be your u in this integral if I was to show it? 3x. So don't I have to offset that 3 by doing a 1/3 cosine of 3x, but wait, derivative of cosine is a negative. Now, can you have scratch paper and can you take this integral off to the side and make sure you have it right? Yes. But those of you that have been doing integrals like in more of a mental math fashion, question, this is where that skill is going to come in very handy, because you have to do a little baby integral, but you might have a chain rule. Does that kind of make sense? Okay. So once we've taken part of it and been like, hey, you're you, got it, you're DV. Make sure you don't leave anyone out, or else you've just messed up the whole problem. Now I can go ahead and do, hey guys, why is it called Lucky 7? Ultraviolet voodoo. Hey, it's 7. If you set it up that way. Now there are different ways of setting it up. It's not always a 7. This is what this guy named Mr. Calculus, he has his whole website. He's always the first one to have the solutions to the FRQs, or at least his version. He leads a room in the AP grading. He's a big guy. His high school down in Diamond Bar has like the highest passing percentage rate in, it's crazy. Did we watch him? No, he doesn't really do videos. Oh no, that guy's just entertaining. Anyway, and that's not really an AP like preparation video. That's more of a basics. That's kind of just for all calculus colleges. The guy was like, gotta go faster, guys. Anyway, how does the formula go? U V. Can I put the negative 1/3 in front? My life is better if it's like that. U V minus the integral of. Why am I writing the negative 1/3 in front? It's a coefficient, it's a constant. He's allowed to come out. Who's never allowed to come out of an integral? Anything with variables. Okay, so minus voodoo, this guy. Oh, it's just a 1. Cosine 3x dx. So what do I end up with as my final answer? Do I need a plus c yet? No, because when I integrate this, what am I supposed to be getting? Got it. So, negative 1/3 x cosine 3x. Sorry, where's the answer? Saying it and not writing it. Struggle. Plus, right, minus a negative, 1/3. Isn't that going to be a sine of 3x, but once again, I have to worry about my u and my u prime of 3. To put the 3, I have to put another 1/3. Wouldn't that actually be 1/9? Some of you never started doing integration with mental math. It is okay. The only struggle is I'm probably going to start going, it's a sine, lo siento, it's a sine. Integrate. Derivative of sine is a positive cosine. Got him. I'm probably going to start going too fast. That's my warning. You didn't start doing integrals with mental math with like u sub. I might start going too fast. Now, that doesn't mean for you to freak out and just throw down your pencil in like aggravation and frustration and I don't know what else. However, if I were you, maybe show the work and then just have a different colored pen to put a little question mark if you don't know how I ever jump. Does that make sense? Like a calc chat jump, be like, wait, how'd you make this jump in class? And I can make sure you understand. Is that okay? So did I jump a little bit? I did a U sub in my head. Can some of you make the jump? Can some of you sometimes make it? And can some of you just need to always show the work and that's okay? Yeah. So, what do you think you're going to always do if you ever see, I had a whole page to show work. What do you think you're always going to do if you see an X with something funny? What's something funny? A sine. What's something funny? An E. What's something funny? An ln. Wait. Let's do something with an ln. Maybe this is a little mean. Can I do one first? Hold on. Don't write that one down. Hold on. I loved my lead-in, but my lead-in did not lead here. My lead-in led here. Right? What if I was to give you this integral? X times ln of x. I know it's cold. I am so sorry. It's okay. Let the math stimulate our brains. The fury of our solving increase our body temperature. Okay, so we have x ln of x. If I was to say, I showed you the other example first, and I already told you kind of the answer. Oh well. Just think through with me. If you were to start to try to do this one right now, what would most of you think? Like off the top of your head, if it was directly after that example, this slide was waiting, I need to put this if you did do, maybe pencils down, don't do it. If you did do, I probably in a future year will just make them play with it. If you did do x, which is really nice and it does derive down to b1 dx, what are you going to be stuck with over here? Now, did we write down that there is an integral of ln of x that you can memorize? Yes. Is it nice? No. And does it look like ultraviolet voodoo? Long story short, is this a nice, able to be integrated without some random special rule that we're supposed to memorize? Yeah, no. So wait a minute. I wonder if we could, since ln isn't exactly a nice integral, I wonder if we can put ln over here and dv over here. We can integrate x. It's possible. We've just been liking that u prime of x is 1. What's u prime of ln? Also simpler. Also simpler. What once had an ln no longer does. What? An integral that had ln. Oh, just give me a second. Hold on. It's time for ultraviolet voodoo. I have to do my 1/2 x squared. Right? My integral had an ln, but what that integral equals for integration by parts, which is going to be 1/2 x squared ln of x, will no longer have an ln. I can pull the 1/2 out. I have x squared over x, which is just x. Oh my goodness, look at how nice that is. Even though x being a u whose u prime is 1 can be very, very helpful for e to the x and sine of x and all these guys whose integrals I know. If it's a guy whose integral I don't know, let's throw him over here and see if his derivative makes everything possible. So the final answer is 1/2 x squared ln of x minus 1/2. Isn't that x squared over 2 again? That's going to be 1/4. P.S. How can we still check any integral problem? Are you going to get a little baby product rule? Is stuff going to cancel out and you're going to be left with that? And the derivative of any constant is 0? So, question, is x always going to be your u? No. If there's a log, the log is a u. What's something else? I'm coming to you, John. What's something else, just to be pondering while I answer John's question, what's something else whose derivative would take something very nasty to integrate and make it look more like something that we can do? Think about it.
The integral, is it supposed to be just x or is it x squared?
Technically it's 1/2 x squared times 1 over x, so I just went ahead and simplified it.
Oh, okay.
Does that make sense? Sorry. Yeah. When I did my voodoo, I just went ahead and said x squared over x is x. Yeah, good call. So yeah, it should be that. Did anybody think of anything else besides ln? I can't integrate ln. Ooh, I can integrate 1 over x. I can actually integrate a squared though. I can integrate an x squared. I can derive it too. Something else whose derivative totally changes its form. Sadly, a number to the x, well, it's both sad and good. A number to the x, his derivative is still a number to the x, so no form change. So technically I think like a b to the x or an e to the x could go in either spot. Just the sad thing is the derivative won't ever get simpler. Like sine or any trig, isn't it going to keep on cycling? Although anything besides sine and cosine actually gets worse because you have like secant squared. Oh, I have to use like chain rule and secant tangent. Oh, I have to use product rule. Inverse trig is the only other derivative that changes the form. Derivative of ln of x is 1 over x. Changes the form from a log to a rational function. Inverse trig changes the form from having an inverse trig to just being a rational function, 1 over u squared plus 1, or 1 over square root of 1 minus u squared. It changes it to something that, oh, we've seen polynomial, rational, division-y things before. So logarithms are good for u's because they can't be integrated. Inverse trig is good for u's because they can't be integrated. Has anybody taken an integral of a sine inverse lately? Well, we actually did one, but we had the u prime there along with it. So inverse trig is good. And then we already know that x can be really good, x or x squared or x cubed, because every time you derive, it'll get better. So let's see. Logarithms are good use. Inverse trig are good use. Algebraic expressions are good use. And then if none of those are there to be used, maybe we have to go to trig, and maybe if trig isn't there, we have to go to exponential. Oh my goodness. L-I-A-T-E. Liate. It's the order to choose the u. Try logs, then try inverse trig, then see if there's an algebraic, and then go see if there's a trig, and then go see if there's an exponential. Liate. The order to choose the u. That's why it's next to you, my kids. Okay. So, once we see liate, which usually works, you're welcome. You look at something like this and you say, that doesn't look like integration by parts at all because there's no parts. Or are there? It looks like a u squared, but wouldn't my u prime be 1 over x, and I don't have a 1 over x, and if I multiply by x over x, I can't pull anything out. I'm telling you it's an integration by parts. My question is, who do you? Some of you are like, you could split it up. But didn't we just talk about how, okay, there's a rule that you can memorize. We'll see where it comes from in a second. But, pause. You could have done that, but how do I integrate ln? But wait, if you do that, Lainey said ln x like is u, so ln of x squared is u. Who's this then? If that's everybody, well, it's not everybody. What's the integral of dx? 1. No, that's what's in there. The 1 is in there. What's the integral of 1? X. When else in integration can you take a derivative before you integrate? Integration by parts says, sure, you can take my derivative. Why? But okay. Take the derivative. So I have 2 ln of x times 1 over x. Right? Chain rule. 2u times u prime. That just made it work. The ln of x squared is now just an ln of x. It looks a little simpler to me. But it has a 1 over x. Well, hold on. Let's just see what happens. So we take that. We take it over here. And say, oh, sometimes you got to go into make sure you're taking the wisest steps. So the 2 comes out. Integral comes in. X over x is just 1, yeah? Wait, pause. I'm doing voodoo. I'm doing v times du, but the x over x will reduce, yeah? So I just get an ln of x inside. Okay, if we just memorize that really gross, disgusting formula, then we'll have the answer. Or we realize that when we put the ln in the u a second ago, it became more possible. Now it's an ln of x instead of ln of x squared. I wonder if we did it again. Oh, don't start groaning yet. It gets way better. Okay, so put in an out, not this problem, but example problem. So liate, I have a logarithm, put them in. Who's this guy? Dx. Yeah. I take a derivative. Aha, my logarithm is gone. It's a little evil, I know, but 'tis true. Don't worry, he's there. He's back here. He's fine. Integrate, and I get x. Are we okay with the derived down integrate up? And I mean, we can tell, right? It's a du derivative, and it's a just v. Lucky 7 time. Now here's the struggle. Isn't this me just rewriting this guy? So just like in Algebra 1, they have a factoring test this Friday. You guys, if you want to tutor some Algebra 1 kids, it'd be amazing. When you pull out a GCF in factoring, doesn't he have to stay? Right? You pull out a 2x from everybody, it's a part of the factoring at the end. Ooh, synthetic division with polynomials. You like do synthetic division with an x minus 5. It's a part of the answer at the end. Okay. You guys realize my answer is x ln of x squared minus 2 times the new ultraviolet voodoo, right? I'm taking my integration by parts and plugging it into the place where it belongs. So I have x ln of x minus, oh, hey, what's the voodoo become? X over x is just 1. Oh, it's the integral of 1 dx. Hey, cool kids, anybody actually start memorizing that whole integral of an ln thing? Because we're taking an integral of an ln and we're getting x ln of x minus the integral of 1 is x. Oh my goodness, that's a rule that you could memorize if you really want to. Maybe it'll save you a couple seconds on a couple questions. Maybe it won't. Anyway, let's see. What? No, the c belongs in there. Oh, come on, you know me better than that. It's a constant times a negative 2. It's still another arbitrary constant. Whatever. It's plus equals. I'm dealing with it very tritely. In more complicated problems, it's very important to keep it in its proper place. What I end up with? So, anybody see that was the answer in the very beginning of that problem? No. Exactly. We go through the process.
So why is it minus the integral of dx
It was an x, but it was an x times a 1 over x dx. And so I just simplified it in my head. Because it's voodoo, it's him times him. X over. See it?
So for like easy integrals by parts, like the what do you call
The
it?
x sine of x.
Yeah. If you flip the u and v and like set them to different things, would it still be the same?
Careful. If you, for the x sine of x1, like the one that we saw yesterday and we tried to kind of mimic today, it would have been impossible the other direction, because even though you can derive sine of 3x, you can derive it, and even though you can integrate x, your resulting voodoo integral would have had, let's see, if x was here, it would have had a 1/2 x squared and it would have had a cosine of x. You just made your problem worse. So what's stuck in the integral is a harder expression that you still can't do. It would be like an x squared and a cosine of x, which is even worse than just a single x sine of x. Well, sine of 2, sorry. Does that make sense? Yeah.
So would it ever get to the point where like we would have to find like past v and use something like w and like
I see what you're saying. In a way, we're doing w's just in the context of we already have a u, we already have a v, so our whole chain rule, if someone needed to show work, would have to be a w in context of the problem. But as far as there being an additional variable in our integration by parts, we always think about it in terms of t. But there might be chain rules in your derivative and in your integrals where if you actually need to show work, you might be using w's and j's and p's, and I'm making up for this. Yeah.
If it's like ever u over v, so like I remember like last lesson I think.
Okay. You're saying a u over v, and I get what you're saying because you're trying to assign letters to, let's call it f over g, and let's say that u could be f and v dv could be 1 over g. Does that make sense? You would have to think about it as multiplication, not division. Is that good? Got it. Oh, hey, look, Liate. If you guys want to write down anything, you totally can. This is just a hint page, and I think I've given you all the hints, but some of you have heard them, and that's different than actually taking note of it. Note, literally noting it. Or, like, note in your head that you'll remember. So, this is Liate. That's what I was already saying. It's a hint for how to choose u with logarithmic, inverse, trig, algebraic, geometric, exponential. However, these are also good things to keep in mind. Now, we've already talked about how u choosing u where the derivative is simpler, and sometimes that means taking a derivative of an ln and the ln's thank goodness, or taking a derivative of an inverse trig and the inverse trig is gone, thank goodness. Ln's and inverse trig, I don't mind if I'm taking a derivative, or I don't mind if I see their derivatives and I'm integrating, but I never want to see them inside an integral. I rarely want to see them inside an integral. But it's not enough to just say, hey, just choose u so that the derivative is simpler. Hey, it's always x, the derivative is 1. Nope. I also have to choose dv in a way that it can be integrated, and in a way that u's derivative and v's integral is a simpler expression for me to integrate. Usually. We've been including dx in the dv, so we've been doing everything legally, which is super helpful. But this is also saying sometimes if it's possible to integrate the most complicated expression in dv, that can also be helpful. But guys, please hear me when I say this can be the way to choose. This can be the way to choose. This can be the way to choose. What am I not saying? Has to be. I'm not saying it must be. I'm just saying it can be depending on the problem. Sorry. Okay. Hold on to it if you want to bring it up later. Bloop. So, ready, set, I don't know, choose one, go. Yes, it's x times e to the negative 4x. Don't worry, it's not that bad yet. It never gets bad, it just gets fun. Oh, come on, at least most of you are awake today. Hey, not just you, there are multiple ones that struggle sometimes. You're interested, you're stimulated. You can talk in your groups if you want. You can bust it out on your own if you want.
I think so.
Yes, this is a short one.
No, it's negative 1 over x.
4. Yeah, I was right.
Double check each other's mental math on the integrating, please.
Oh, wait. Dang it, I shouldn't have said that.
I thought it was negative 1 over x. I mean, honestly, it doesn't really matter what you do.
I'm going fast. I love you. I just can't give you forever. Hopefully you made your u x.
Easy to integrate.
Oh, yeah.
But like e to the negative 4x is
Oh,
u.
oh well. It's okay. What?
Yeah,
Or
same.
look, she didn't do that. Wow.
I don't know, what did she say?
I said
Were you
that.
right?
Yeah, look, she did.
Do you see it? If I had made the e the u, wouldn't this derivative have been just the same, and then the integral of x would have been worse, and it just would have not been anywhere nice? As you do more of these, you'll answer a yes much quicker. That one, yep. See how the x with a trig? Yeah, the x is the u. The x with an exponential? Yep. Algebraic wins over almost everyone except for logarithmic or inverse trig. But guys, you gotta get to harder. You ready? You check out the video. Don't worry. Just skip a couple lines if you haven't gotten there yet. I did my plus C. Had to double check.
It's like what she
According to Liate, wouldn't we put the x cubed over x squared plus 1 all quantity squared in the u spot because it's algebraic, whereas the other guy is exponential? According to Liate, that's what we would do. But can you imagine what that derivative would have been like? Quotient rule. And can you imagine how well our integration would have gone over here? That's an e to the u. Don't I need a u prime in order to integrate? And the u prime is 2x and there's no x? Now, could we steal an x? We could steal an x. We could separate this and we could have done an x, e to the 2x. Oh, sorry, x squared. Sorry. I'm thinking of my u prime. And then all of a sudden, I could go back to my 1/2 e to the x squared. Okay, that would be a legal integral. Okay, that's messy. I know. I have to adjust. If I had a little x in front, all of a sudden, this guy is possible to integrate because, check it, my u would be an x squared. My du would be a 2x. I'm missing a 2. I need a 1/2. I got it. But what would I still have to do over here with the remaining? Well, I stole an x, so wouldn't that just be an x squared? And after you do a quotient rule, won't you still have an e to the? Any other ideas? Switch it? Lorenzo, what are you saying your u should be?
X squared times
So he's thinking of what can I integrate? And he's saying, hey, I could integrate this guy because u would be x squared plus 1, du would be 2x. Oh, okay, I could integrate him because I could make this into a 1/2 integral of 1 over, he's u, he can't be u. Okay, fine, w squared dw. Oh, I could integrate that. What would that integral become? Because that'd be w to the -2, right? And w to the -2 integrates to be -1 over w to the 1, so that'd be 1 over -2w, which is x squared plus 1. Maybe that's easier. What would this guy become?
2x e to the x squared plus, I guess, x.
What? He's doing a quotient rule? Because it'd be 2x cubed.
I was going to try to simplify it, but. How am I going to write myself?
Oh. Second d first plus first d second. We got it, right? Wait, there's stuff in common. Maybe that helps. So I could pull out a 2, I could pull out an x, I could pull out an e to an x squared, and I would end up with 1 plus x squared. Now, do you see how some of you might not see exactly whether or not this is going in a pretty direction or not? Because that would be negative x squared e to the x squared all over. I'm just doing my ultraviolet, my UV, minus v du. Okay, hold on. I'm choosing this version of my du. Okay. So I have minus a negative, so plus an integral of. I do have a 1/2, but it's times a 2, so that's going to simplify away. And then my 1 plus x squared and x squared plus 1 will simplify away. So all I have left is an x and an e to the x squared. Oh no, we have to do integration by parts again. Oh wait. What if my u was x squared? What would my du be? It'd be 2x. This is super nice because then all I have to do is offset by 1/2. That was a really hard problem. Just Lorenzo made it look easy. And me. Because who would you have chosen? Would you have chosen him to be your DB, but then he would have had to steal an x to make, you had to steal an x to make it possible. So when the 2's reduced and when the 1 plus x squared is reduced and when you had an x e to the x squared, you had a good old-fashioned u sub that you could have gone ahead and done off to the side with u and du. But Lorenzo was very weird and strategic. Why did he have x squared e to the, like, what? It's because he needed this to be able to integrate, and to be able to integrate it, he needed the u to have a u prime to offset it by. And didn't I do an awful lot of mental math with my integration? Okay. You might want to take a picture and you might want to watch it on YouTube, this portion of the video, and slowly pause and make sure you understand the steps. This was hard. And in years past, Lorenzo hadn't brought that up, we would have been rabbit holing for a long time, trying to figure out what the right combination was. Whew! So what about, look, it's fun font. We never have fun font. It's a loopy font. Because it's loopy. What? Why is it loopy? Who's your you? Who's your you? Because E! But then du is E, and E, and E, and E, and E, and dv is sine, cosine, sine, cosine, cosine, sine, cosine, sine, cosine, sine. Nothing ever gets easier. Oh, we must flip it. Make your u the cosine. du is sine. dv is E, and then the v is E. It's just going to loop and loop and loop and loop and loop. Nothing ever gets simpler. All of integration by parts is built on u getting simpler. Sorry, Victor, I've been having way too much fun.
It's okay.
All integration by parts is built on u being simpler, right? Not this one. No. Lo siento, I'm so sorry I don't have a lot of time, and I want you to be armed with it for the maybe 1 or 2 in homework. P.S. The AP loves this one too. You guys get to choose, and I will just follow you. Who do you want to be you? And I can tell you right now, it won't make a difference. Whatever you choose, though, we have to keep going that route. So if you choose exponential, then we keep on doing exponential the whole time, the whole time, the whole time. I'm hearing E by Abby. Abby. Try me. Latte. Try me. Forward to 2. It didn't get any better. All right, we have to go again. It's not going to get any better. Nope, believe me. For some of your brains are going to be your worst enemies until you see how it works. Because some of you have to always know how it's going to work out. Exactly. But you just have to keep going in the same direction. Remember. You want to see how it works out? You can say, if you want to check it out tonight, when you get to one of these in homework, you can leave. Minus a negative is going to be 2 less.
I'm just gonna not say anything.
Here's the key, right here.
I'm going to perform
What was it? Hate speech is free speech. I started the argument off with I like that.
Yeah, and they like people of all ages.
All ages? You say all ages?
Woo! You ready? It's impossible. You will loop and loop and loop and loop and loop and loop and loop. What is she doing? She's adding it to the other side because they are like. Use the loopiness to your advantage. 1 plus 4 is 5. Bye, guys. So there's homework problems. My problem is don't forget your plus C
Oh, wait.
right now. You gotta actually solve it.
Thank you, Patricia.
You know how many jokes like that I get?
You have to figure out the coefficient without the coefficient. Because you can't hear because they don't have this. See? So it has to cycle all the ways. Right?
I still a 4.
Yeah. Thank you. I'm done. I just don't like this. I could almost factor something out, but that plus C kind of stopped me. But I could factor out and then leave the plus C off to the side. But
Math is this.
algebra saves the day.
Did you hear that, Andrew Bosch? Algebra saves the day.
Or Miss